Hello and welcome back to the lab. Today on the bench we have the 475A. Again, the last video I released about repairing the power supply and everything in this unit, I got a lot of questions through email, and I got some comments on the video about the TI sockets and my issue with TI sockets. And the impression I got from some of those comments was I was unfairly harsh to Texas Instruments sockets. So I'm going to make a video to address that. Obviously, YouTube is kind of strange. You guys can leave me comments. All I can do is make a video. I do read all the comments, so if there's any questions about anything that anybody sees on the bench or needs clarification on, do not hesitate to drop me a line, because I do read all the comments. Even if I don't get a chance to respond to them, I do read them. I love talking with everybody who's watching the channel, and it also lets me know what everybody wants to see and gives me ideas for additional content. So if enough people leave me comments, I'll make a video. So in this particular case, I was talking about the IC sockets that are on this particular unit, and I was mentioning the TI sockets. I do not want to come off unduly harsh against Texas Instruments. I like a lot of Texas Instruments stuff. I even like their modern sockets. This is specifically a problem with the sockets that they made of this vintage for things that are of this age. There's a design flaw in these sockets where they get much more unreliable than a traditional style socket, and they do cause connection issues quite often. If you're having some connection issues with the socket, they are very easily replaced with many things modern. Just anything of a good quality. Socket is a pretty simple device. Not much that can go on there. This particular design is pretty bad. One of the reasons sockets were used in devices of this age is back when some of this stuff was put together, ICs were very expensive. I remember my dad buying LEDs, individual LEDs, especially when a new color of LED came out, because I do predate LEDs. But I can remember him paying like $4 for an LED of in single quantity. So ICs and things like that were very expensive back then. And this let a manufacturer build a board, have all the sockets there, but they weren't chewing up the IC inventory. They could have the board with the sockets sitting on the shelf. Somebody would order a board. They could populate all the ICs and then put it in the device and send it off. So it allowed for a lot of pre-production, but also without a whole bunch of needing a large inventory of ICs. And we're also talking back in the day where a single op amp could run $20-ish. We've come a long way. The other thing, it helped in manufacturing too with failure rates. ICs of this age are not as robust as ICs of today. They're much more susceptible to static shock. They're more easily damaged. They were far more susceptible to overheating through a soldering process. So what it let manufacturers do is you populate a board with sockets, send it through the wave soldering machine, and none of the ICs would get overheated during the soldering application. It allowed for reject rates or failure rates to be less because none of the ICs were thermally damaged. It also helped in with reliability of early silicon. This stuff did kind of fall off. I mean, just this particular DM4400 had a bad IC on it, which is why the meter wasn't working. It helped with troubleshooting and repair and replacing it as a service tech, when you used to be able to do component level troubleshooting. Because devices were so much more expensive than they are now, nothing was really disposable. Back then, everything was repaired. These scopes were designed to be repaired. Everything was made to be fixed. It was expected that people would replace ICs, and unsoldering a multi-legged IC without a desolder tool, especially in the field, is rough. So a socket allows somebody to use a tool like this, where you just get it under and pry it up. Once you've isolated the bad IC, pull it out, put a new one in, and you are good to go. All this stuff was made to be serviced. Yet another reason to use a socket is these PIC microcontrollers can be updated. This is the Tontec IC tester that I built a couple of videos ago. And these can be updated, but I wouldn't want to have to resolder all the pins. That's a lot of thermal stress on it if I had to pull this out, put it in a pin tester, or put it in a programmer, flash the new program, put it back in. So the sockets allow me to just pop the ICs out, program them, pop them back in. So anytime you have to deal with firmware or something like that on a programmable IC, sockets are also a benefit there. Especially with the soldering iron, keeping the thermal stress off the pins does wonders for the longevity of the IC. Okay, here we have a modern IC socket. I believe, for those who are interested in such things, this is the part number. Believe these are Amphenol sockets. I keep them in a rail, and I did label them completely with what the part is. So we have a 14-pin socket, which means we're going to have 7 on a side. Now on these, there's a little notch here, and typically that keys for pin 1. So there'll be a notch on the IC, and that goes out. So this notch should always face pin 1 because it helps orient the IC during assembly. But you'll notice the way the socket's built, and this is the important part and the difference between the modern sockets and these vintage TI sockets. These have a cup, so there's a contact that goes down to the bottom and then comes back up, and these are spring-loaded, so they grab the pins of the IC tightly, and these make a good electrical connection. They go all the way down, they come back up, and then they come over, and then they come down out of the connector. But these make a great electrical connection, and actually getting the IC out of these can kind of be a pain in the butt because they grab so tight and they really hold on to the pins well, and that's the important part. This is not the case with the old or with the vintage TI sockets. Modern TI sockets are designed this way and are built this way, so everything is good to go there. But vintage ones are different. So now, as you can see, I'll just lay the modern socket next to it. There's a drastic difference between these two sockets. So we have a modern 14 pin, and then we have the vintage TI pin, and you can actually see, let me get a better pointer. So one thing to note, just in the quick glance, is the contact area on these pins is so much bigger than the contact area on these. And even the insertion area is so much smaller on the vintage socket than it is on the modern socket. There's a lot of room to hit these pins and not mash an IC pin and bend it in sideways or out or anything like that where it didn't line up with the hole just right and it shoots out sideways and things like that. So these are actually kind of a pain in the butt to line up. I also don't like these IC sockets because they're not keyed. They really don't do a good job telling you which side's pin 1. However, on well annotated designs, that's usually marked on the board so you'll know which side's pin 1. But the other thing is, if you look in here real close, like in this hole right here, you can see the contact pins that are coming in. but they're on the sides of the IC pin. So if I bring this IC back in here real quick, we'll just set this here. So where the pins of the IC enter in the hole and then the socket makes the electrical connection to the IC, instead of grabbing on this flat part of the IC front and back like the modern socket does, this grabs on the sides of the socket. Now, that was done to avoid a patent back in the day. Okay, this particular model of TI socket are the C93 sockets, and these are the ones that have a problem. The C95s actually do not have these side connecting contacts. And the main problem is these side connecting contacts. So they do a couple of them. There's not a lot of meat on the side of that IC pin that the connection's making. So over time, the connections get a little flaky. The other couple of problems is these IC legs tend to be stamped as they go down the assembly line. So there's a burr on the sides in the back where the stamping press punches out the leg profile. That sharp burr can cut into the socket, catch things, drag things, bend the contacts, because these contacts are very small. And the other problem is, because it's not a good flat surface, these aren't gas-tight connections. So they're exposed to air and moisture, which causes some oxidation problems, wiggling the IC in the socket, and once they oxidize, the connections go resistive, and then they end up making, they end up being intermittent. Now with low voltage 74 series logic, this doesn't seem to be, they seem to be less problematic. They're still problematic. I've had a couple, especially I think the last time I talked about these TI sockets was in my AA501 maybe. I think that was the video that I kind of went into these a little bit because I had to replace a few. The audio analyzer, which is a past video in the channel. But not having the gas tight seal means the contact goes high resistance. Now for ECL logic, they that can cause some problems because the ECL has a higher current on the pins. So they sometimes can be left in, sometimes can be not left in. It all depends. Also, the target for inserting and pulling out the ICs is very small. One of the reasons why when I went through and did this DMM, I reseated all the ICs because it scraped all the oxidation off and got a better connection. So if one of these sockets, if pulling the IC out and reinserting it does not fix the problem, just replace the socket. Don't fight with it. Don't argue with it. Just get it out of there and get a good quality, any good quality replacement that physically fits is really all anybody needs. One other interesting way that Tech did a few things with sockets is they made individual sockets where they put individual socketed pins on the board. I typically do not see problems with these connections much, and especially with this one. You can note, I'll film it from the other side, but there's a pin that sticks way out. I don't know why they did this on this particular IC. Everything's lined up except this one pin's way out here. So let me get this other IC put back in, and then we'll film this from the front. But this is a board level socket that Tech used, and I've run across it a few times. And they use it a lot with transistors. Here's the other side of that particular IC, where the connections just stood way off the side of the board. This leg comes straight out and then comes into a pin that's proud of the board. So I'm not 100% sure why Tech needed to do that on the DM44s, but that was a little bit weird. These are just a bunch of what the transistor sockets are. So this would be one of the custom Tech hybrids. We can see more of those elastomer sockets that work well. These typically do not fail. So these particular sockets, I have very few problems out of them. Every once in a while, one gets a little dirty, just needs a little bit of cleaning, but very robust design, and I do not have much problems with those. However, I do salvage them off boards when I need to. If a scope does end up going completely terminal, I do end up pulling as many of those off as I can, because I found out you can still buy them from Tech, but they're kind of expensive. So saving them is good. And here is just a random transistor that will pop off the board. And we have 3 of those sockets that are just sitting in the board for the transistor pins. Usually what I'll do as a maintenance item for the scope is I'll just wiggle all the transistors. I won't even pull them completely out. Put this guy back in. I'll just move them around a little bit like that, and that's all it needs to clean them up. So very robust design on that one. Those are good and don't need much. This is also not a Tektronix problem with these TI sockets. These were used in a lot of things of this age. I found a lot of references to these sockets being used in Apple I's and a few other things, so definitely something to keep a lookout for. But that's why I don't like those specific TI sockets, and why I've needed to replace a few of them. Thanks again for stopping by the lab. I hope this video sheds some light onto why I was, and I hope I wasn't unduly harsh on TI sockets. I do like a lot of what TI makes. It's just this vintage, very problematic. So, as with anything, I will see everybody in the comments section, and I will also see everybody in the next video. More is on the way.